So from our list, top 50 frequently asked data structures and algorithms problems. The third problem is you have to find the given array has duplicates or not. Okay. Problem is that this is actually lead code problem contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. For example, one, you take nums 1, 2, 3, 1. So 1 is repeating, so returning true. Similarly, in case of example 2, all numbers are different, so you can return false. In example 3, you have the many duplicates, 1 also repeated, 3 also repeated, even 4 also repeated, 2 also repeated, all repeated, so you can return true. So this problem we can solve in different ways. We'll discuss about each one of these things. Okay. And yeah, uh, we'll take this example one and we'll try to analyze like what kind of how many ways we can solve this problem. uh, One, what are the inputs? 1 2 3 1 1 2 3 and 1, right? So one always, right, you need to think about how we can solve any problem through brute force and try to understand what are the how we can optimize afterwards. That is the best way to do any always actually. Okay. So in this case what we will do is we'll start from the element here I. Basically we'll take two loops. That is the brute force. Example one, that is brute force. Okay. So brute force approach is basically you can loop for two loops. We can start from I here, and j you can start from here. Okay. And compare 1 and 2 are equal. If no, then move this pointer to next element j. Now j is actually now 3. Compare 1 and 3 is are same. No, then uh, you can't compare with, I mean, not same, so you can move ahead uh, with next element and so on. After that so after this actually what we can do, we can change the high oops we can change the high position from 1 to 2. If you found already here this duplicate, then you can return here. In case it is not there, then I will change to here and j start from here and so on. So this is the brute force approach, right? And the next solution could be, um, it's not optimized solution or in terms of time complexity, but it's okay, reasonable only. So what we can do is we can by using the sort. Okay, we can sort the elements with big O of n log n time complexity, and then you can just compare with O of n with one with linear comparison of elements. Okay, so in case of this example, once you sort it, what will the output of this one is? It will come 1 1 2 and 3, right? This is how it will be sorted. When this is sorted, then you need to compare I plus 1 and so on and so on. Compare, if found any duplicate, return here. In this case you will return now only, right? This is also this is second solution. And third solution is actually better than this one, but we will use some extra memory using any map, like map. We can use map So once we use map, what will happen for this case actually? um, Map, initially you just check this number, right? uh, this number exists in the map or not. In the map nothing is there initially, no comparison. So here you can't compare, so one will be with boolean we can say one is mapped, one is in the map. And when I move to second, I will check if the two is available or not in the map. No, then we can put two also in the map. Then we'll move to three also you can not there in the map, so you can keep it off true. So finally one is there, so you just return true uh, from the map. So in this case actually this will be like a O of n time complexity, because and space also big O of n only. Okay, we will try to implement three solutions and try to understand how it goes. Okay, so coming to hands-on thing, I hope you understand there are three possible solutions for this particular problem. One is brute force. This is actually O of n square time complexity. Okay, and by sorting and comparing with neighbors, this will be n log n. And third is actually using map, which will be O of n time, but extra memory also there. Okay, that's it. Maybe to mark it the time complexities, you can take this one as one, and this is the time complexity, and this is the time and space complexities. Okay, let's try to implement this with one solution. First solution will be like a brute force approach, right? So brute force, as I mentioned, we need to use two loops. Well, loop one will be start from I, and the second loop will start from I plus 1, and just try to compare it. It's a very simple approach. Probably I can take the length, maybe number of elements is length of nums, because I don't want to call again and again. So here first loop will be for I equal to 0, I less than n or minus 1 basically, and I plus plus y minus 1, because next per loop will go with 2 n act, otherwise it will come uh, over exception actually. It will be panic basically in Golang. So here actually we will try to start from I plus 1, j is less than n, and j plus plus. So what we will do here is a very simple condition. Nums of I equal to nums of j. This is the case, simply written. Otherwise return false. This is the simple solution basically, and this is the brute force solution. So this will be like nested loops we are using. That's why this time complexity will be O of n square. Okay, big O of n means the number of elements in a array. Okay, this is the time complexity for this solution. So second solution is what we discussed is sorting, right? By sort actually, um, so what we can do is we can I just comment this way. Okay, so what we can do is we can use the sort method sort ints of nums, right? This will sort basically all the numbers. Then what we will do is we will just try to compare the elements. Okay, for this is actually one for loop only, right? Equal to 1, start from 1, and I less than n, I plus plus. Just need to see if nums of I equal to nums of I minus 1. If this is the case, just return true. Else anyway we have the false, right? This is the actually big O of n log n time complexity. This is n. Basically, the sorting will take any algorithm like a merge sort or bubble sort will take n square. But assuming that we are using merge sort or quick sort, which will actually gives the results in n log n. Okay, the solution basically big O of n log n. Okay. Okay, so next solution, we saw it. This is also working fine. And the next solution next solution what we will think of is using map. Okay, so what we will do is we'll create a map. Okay, uh, a map make of map of int of bool. So we'll create a map, and here actually we are not going to sort, use any sort or something. Sort actually took n log n time complexity, whatever the algorithm we can use. So here what you will use the nums from numbers. Okay, just check, we will just check that if nums of, sorry, if the map of num is present or not. If it is present, return true. Otherwise what we can do is map of num equal to true. We'll initialize that. Okay, otherwise it will be return null. So here we are using extra space, uh, big O of n, oops, space and big O of n, time to solve this problem. Okay, let us run this one. Let's see any errors will come. Sorry, range. Oops, clarify and declared and never used. Okay, I think this is not required now. But we can use for loop also, but anyway we are trying to use range only. Okay, this is the best solution in terms of time complexity, because one iteration actually we are able to solve the problem. Okay, uh, that's it about this problem. Uh, Contains a duplicate problem, which is actually third problem from our top 50 data structures and algorithms. This implementation using Golang. Okay.